Hi, welcome back to Limits in Calculus. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. In this video, we're going to go over a type of technique to solve certain limits called conjugates. Okay, this is limits by conjugates. All right. What is a conjugate? All right. So suppose I have a term here, some number, or it could be a variable, but either one, a plus b. All right. By definition, the conjugate, I'm going to do this in purple, the conjugate of a plus b is just a minus b. Okay, that's the conjugate of this. All right. Also, if you were to put this in terms of like an actual variable, if I had something like x minus 3, what would the conjugate of this be? Well, it would be, in this case, x plus 3. All right, so the conjugate, you have to have a sum or a difference here. Notice I have a plus b. The conjugate is you essentially just, you keep these numbers the same, a and a, right? And then you have b and b. And then if this is adding, then you just multiply by the terms subtracted. Notice here I have x minus 3. This is subtracted. Then I'm just going to multiply by x added to 3. All right? Another example. If I had x squared minus y cubed, what would the conjugate of this be? The conjugate would be x squared plus y cubed. All right? So notice here I have the x squared the same in both cases, the y cubed the same. The difference is here I've subtracted them and here I've added them. That's what a conjugate is. And this is actually very useful for solving limits that have some kind of square root in them. Because it turns out that square roots in limits can actually be a pain to deal with unless you use the conjugate method. All right? So we're going to go over that in just a minute, but I want to cover one other thing first. All right? And this is something that's very important in all types of math, chemistry, physics, and so forth. All right, so let's suppose I have the fraction 3 divided by 3. What is that equal to? It's equal to 1, right? If I have the number 50 divided by 50, what is that equal to? That's equal to 1. If I have variables, suppose I have x cubed divided by x cubed, what is this equal to? It's equal to 1. If I have 10 to the 5.34, some exponent, divided by 10 to the 5.34 power, what is this equal to? It's equal to 1. So in other words, if I take any number and divide by the same number, or I take any variable and divide by the exact same variable, it's just equal to 1. Now let me ask you another question. Suppose I have a function y, let's just say it's equal to, y is equal to x to the 4th. Okay, that's the function. Y is equal to x to the 4th. If I multiply by 50 divided by 50, what's this equal to? Well, we just said 50 over 50. This is just 1. What's x to the 4th times 1? It's just x to the 4th. So a thing that's really important, a concept that you really need to understand, is that if I multiply anything, a number, a function, anything times 1, it's the same thing. All right? It doesn't change the value of the expression. So in other words, if I take any function or number and multiply by what is called a fancy one, which is just like 3 over 3, 50 over 50, x cubed over x cubed, it doesn't change the value because that's equal to 1. Likewise, I could take, if I have y is equal to x to the 4th, what if I multiply by x minus 3 divided by x minus 3? Well, this is actually a term here, but I still have what's in the numerator, x minus 3, divided by what's in the denominator, x minus 3. So this thing right here is still 1. Okay, you're just dividing and multiplying by the same thing. So again, this is just equal to x to the 4th. So one of the things when you do limits is you have to make sure not to change the value of the limit. And one way to do that, to manipulate things, is to multiply by this thing called a fancy 1. It's not really it's not a mathematical term. It's just something that we just call it. It's a fancy 1. So another example, just to drive the point home, this could be 10,000 x to the fifth divided by 10,000 x to the fifth. It's still 1. I don't care what the number is in the numerator. If I divide by the same thing in the denominator, it's just 1. And so we're going to take advantage of this when we do conjugates to solve limits. So the first thing we're going to do is we're just going to dive into an example and look at two cases. Suppose I have the limit as x goes to 1 of 1 minus the square root of x divided by 1 minus x. All right, I'll just tell you this from experience. The 1 minus square root of x, because there's some kind of square root in there, it's usually pretty difficult to deal with. All right, so one thing we can do is we can either pick to multiply by the conjugate of the numerator, 1 minus square root of x, or we can choose to multiply by the conjugate of the denominator, 1 minus x. So the first thing I'm going to do is I'm going to show you the first thing, and it's actually not going to work. It's not going to work. It's not going to make our problem any easier. It's actually going to make it harder. And that's when we multiply by the conjugate of the thing that's not the square root. So x is not the square root. So what's the conjugate of 1 minus x? Well, it should be 1 plus x, right? So I'm going to take this limit, 1 minus square root of x, and then over 1 minus x, and multiply by this fancy 1. So 1 plus x divided by 1 plus x. That's 1, so I didn't change the value of the expression. All right. In the previous video, when we went over limits by factoring, remember how we talked about where if I have something like 1 minus x squared, remember I have some number minus something that's squared or vice versa. And so I can take the square root of 1, which is 1, and the square root of x squared, which is x, and then my term should be 1 plus this, whatever this is, x, and then 1 minus this, x. So that means 1 minus x squared is equal to 1 plus x times 1 minus x. Well, that's what you see here. I have a 1 minus x times a 1 plus x in the denominator. All right. Well, I'm going to do the reverse process, and it turns out that all you do to do the reverse process is you just take this first number, a 1, and you just square it. So here it's a 1. 1 squared is 1. And then you take the second number, which in this case is an x, and just square it. So I have x squared. And then it's just the first one, 1 squared minus x squared. And I essentially just FOILed it out. And you can actually FOIL it out by hand and prove to yourself that this is it. Now, nothing cancels. All right, nothing cancels. If I plug 1 in here, it's just 1 minus 1, that's 0. So I have some number divided by 0. And can I do that? The answer is, and if I can find my red pen, no. This doesn't work. So what I'm going to do now is instead of multiplying by the conjugate of the thing that doesn't have the square root, I'm going to show you what works, and that's by multiplying by the conjugate of whatever has the square root. In that case, this is 1 minus square root of x. So how can I multiply by a fancy 1 here? Well, I can take the limit as x goes to 1 of 1 minus square root of x over 1 minus x, and multiply by 1 plus the square root of x over 1 plus the square root of x. All right? How does that help me? Well, remember what I do when I have something like this. I take the first number and I square it, so that's the 1 here. And then I take the second number, square root of x, and square it. What's square root of x squared? That's just x, and then you just subtract them. So 1 minus x here. But notice, I have a 1 minus x here in the denominator, and there's a 1 plus square root of x, but I have a 1 minus x divided by 1 minus x. This just cancels, it's 1. So that cancels, and so all I'm left with here is the limit as x goes to 1 of, since this canceled, this is 1 over, and then I have this, 1 plus square root of x. And now I can just plug this 1 in there. All right, so the limit ultimately becomes limit of x goes to 1 of 1 divided by 1 plus, and then if I plug 1 in here, square root of 1 is 1, so 1 over 2, or just 1/2. All right, so here I had this square root thing in the numerator, and I chose to multiply by the conjugate of that. And that's what ultimately got me to where I needed to go. All right. it turns out that even if the square root term is in the denominator, that's still the one that you pick to multiply, to do the conjugate of generally. Okay, sometimes there's an exception, but generally this is what you do. So what would be the conjugate? What would be the conjugate of 3 minus square root of x? Well, the conjugate would be 3 plus square root of x, right? So that means as the limit goes to 3 of 9 minus x over 3 minus square root of x, I'm going to multiply by the conjugate. So it's going to be 3 plus square root of x divided by 3 plus square root of x. All right? So what do I do? Well, I have this 3 minus square root of x times 3 plus square root of x. So what I'm going to do is, excuse me, I'm going to take this first number, 3, and square it. That's a 9. And then I'm going to take the second number, square root of x, it's a variable, and square it. And what's that? That's x. And then I'm just going to subtract them. And that's going to give me this 9 minus x. And then in the numerator, I still have 9 minus x times 3 plus the square root of x. All right? But notice, in this limit now, I have 9 minus x divided by 9 minus x. And they cancel. Okay? Which leaves me with the limit as x goes to 3 of 3 plus square root of x. And now I can just take this 3 and plug it in there. Now, we don't know what the square root of 3 is off the top of our head. It's not a perfect square, so you can't really do much with that. If you have a calculator, if your tests allow calculators, then you're more than welcome to just plug that number in and get a number. Some courses for calculus and other courses don't allow you calculators. So if this is what you got, you would just simply leave this as, let me get this, it'd be 3 plus the square root of 3, and that's a perfectly acceptable answer like that. Okay? So this would be the limit as x goes to 3 for this, this function right here, 9 minus x divided by 3 minus square root of x. All right? So one of the key takeaways of why you would ever use this technique is ordinarily where you have some number minus a square root or a square root minus some other number, and those can get really hard to deal with. So you look at whichever term here, in this case it's the numerator, 1 minus square root of x, whichever term has the square root in it, you just pick that and multiply by the conjugate of that. So if I have 1 minus square root of x, I'm going to multiply by, in this case, this was 1 plus square root of x divided by 1 plus square root of x. The thing that you do have to remember, though, is remember, you're not just multiplying by, the conjugate. You're multiplying by the conjugate divided by the conjugate, because that's what we call the fancy one. And the reason you do the fancy one is, remember, it doesn't change the value of the overall expression. Okay? So if you're working problems in the book that you recognize are probably ones that can be solved by limits by conjugates, then make sure to kind of work in the book along with watching this, kind of look at this as an example. I hope this video helped you. This is generally the method, really the only thing you use for solving limits like this. All right. In the next video, we're going to go over another type of limit that we can see, and those are trigonometric limits. All right. So I hope this video helped you. Make sure to like this video and subscribe to the channel for future videos and notifications. Thank you very much. Good luck.